Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit. Today we are doing another AMC 8 problem because the AMC 8 exam is opening today. Remember that this exam is done over a period of time, so your school or testing center maybe has the exam next week. We are giving it to our students next Monday, for example. That's all fine as well. But you can't discuss the problems if you take it today because some more students are taking it. We're excited to be able to discuss the problems with everyone once they're fully finished with testing and we get the go ahead from the competition people to discuss those problems online. Check out our YouTube page, Instagram, Facebook, other social medias for some timing guidelines on the AMC 8 we posted earlier this week. Otherwise, let's jump into the problem for today. Our question of today is involving geometry and in particular a 3D geometry problem. So the figure below shows a polygon ABCDEFGH consisting of rectangles and right triangles. So reading the question here, we have this shape, this polygon. Officially, this is what's called a net because we're cutting it out and folding it, making a 3D shape, a triangular prism. So this is something called a net. It can help you understand the surface area, of course, of this shape. And then the problem gives us some lengths. So anytime you're doing a problem like this, as soon as you're given information, it's good to start writing it down. So AH is EF is 8. So we know these lengths are 8 here. And GH is 14. And this one's a little different because that length is, of course, going to be folded up in that scenario we have here. Now, to really get started with this problem, we're going to want to take advantage of the 3D shape. They tell us when you fold it up, we have a triangular prism. And that gives us a hint in that when we're drawing our picture, we want to think of the base as a triangle. Remember, a prism has some shape as a base. So we have our triangular base here. And the key thing about a prism is the top is the same as the bottom. So if we go about drawing this shape, when we connect the points here, the vertices that we have, the top and bottom are the same identical triangle, and then we can connect the pieces from there. Now, the difficulty of this problem and the key to solving this problem is labeling the points and understanding what happens here. So if we think about our triangular base, right? I have a right angle here in the back, so this point I could label with J. And just trying to fit the diagram a little bit, we would have G here, and then we have B in this case as well. Now, a good place to start would be thinking about what happens if we draw the other triangle there. So, right, we know that BC is connected in that way. We know that GF is connected in that way, right? And then I is going to be connected in the back in this scenario as well. Or not connected, yeah, connected to J actually, but we don't know that much information about things there. Now, here's where a little bit of stuff gets complicated. We might notice that a lot of our letters are missing, right? I don't see an A anywhere. I don't see an H anywhere. We have to kind of think about what happens when we're creating this shape and what happens when we're doing this folding. Now, a good place to start, in my mind, is to think about specific lines and think about how they're folding. And that can really get us some progress here. So if we think about, say, AB, well, that's going to fold over to BC in this shape. So actually, those two highlighted parts become a single edge in this picture here. And this allows us to start making some good progress, because now we can say, wait, if we're folding that line over and they coincide to the line BC up here, we have to have the point C is actually the point A as well. And now we're starting to get into some good shape here. Why is that? Well, and I'm not going to do all the highlighting here, but if we do one more highlighting at least, what if we think about our AH now? What if we think about that line there? Well, if we fold this over, right, it's the AB and A are connected to the C there. Well, where is that H going to be going? In fact, if we fold that over, notice the other triangle is going to come up and meet. So this CI is actually going to be meeting up with that AH there. And so we can start making some progress here and say, well, wait, this is telling us that the H is also the I in this scenario. So that's getting us some good progress here. What's another way of thinking about that? What's another way of thinking about why that makes sense? Well, remember we said in the first picture that I and J are connected. So that I-J connection is coming from H, because H is the same as I. That connection is going to be going in the back there as well. So yeah, let me keep this one highlighted here as well. The AH line there. And from this point, we can start filling in some gaps here. Now, if we want to kind of fill in the final gap, maybe I'll do one final highlighting to start making sense of this picture. What about the F? Where is this FE folding over? Well, this one's similar to what we did with the purple. That's folding over to give us this other side here. So we actually have, okay, the E is folding over to the G in this case as well. Now, why do I think this one is so particularly important in this case? Why is that one important here? Well, we now know that FE, right, or FG in this case, is 8. So that's giving us this 8 that we have here. Well, wait a second. Now, if we have the height of a triangle like this, right, we have this triangular prism. A prism has a set height, and we've now shown that that height is 8. So we actually know that this is 8, and it's kind of mixing up the diagram a little bit, but IJ is also 8 as well. So in fact, if we label these back on this picture here, we have a square that is 8 in that scenario, right? So I could have labeled these rectangle points there too. We have the 8s there as well. Now, one final thing, and now we're going to be making really, really good progress and be close to the end. What if we think about the JG? This is the hard side to say here. This JG in this case, I'll highlight it on the picture here as well, but it's more important to think over here, because we know that GH is 14. Well, if JH is 8, JG has to be 6. So now we have a 6 here. Why is this important? Well, what about our BG then? What can we say for BG? Well, by the Pythagorean theorem, or your triples. So I'm going to write this out in a square root, but if you know your 3, 4, 5 Pythagorean triples, square root of 6 squared plus 8 squared, you know that this is going to be the square root of 100, which is 10. So now we know here we have a 10, we have an 8, right? We actually know all of our shapes here. Now, if you think carefully about this, we don't actually need the 10 to find the volume, but when you're solving these problems, right, don't be afraid. Sometimes it will help let's figure stuff out, right? I took 10 extra seconds to find the 10. I'm now very confident we know all of the lengths in this picture. I'll even now put in this 8 in the background there. We know everything, so we're confident in finding the volume from here. So, right, officially speaking, if you're saying to me in the comments, we don't need the 10, that is correct, but just to put everything together here, the volume is the base times the height. Well, the base is a triangle that is 6, 8, 10. Since it's right, we only need the 6 times 8 divided by 2. That is the area of our base there. And then we multiply by the height, which is also 8 in this scenario there. So we have our base 3 times 8 times 8. So if you want to do this as 24 times 8, or maybe 3 times 64, that would be my preferred way of thinking about this. You will get 192. And regardless, you get answer choice C. So this is a good problem involving geometry, 3D geometry, nets, prisms, a lot of good practice in this case. But if you work carefully, the problem's not too hard to do. That will be good for today's video then. Thanks for watching. Give us a like, give us a comment if you have other ways of doing the problem or other thoughts. Otherwise, stay tuned for a new problem next week. And if you have any ideas of topics or problem requests, be sure to let us know in the comments below. Thanks for watching. Goodbye.